Now what? I guess we keep going down the list. We've done so much today. We've done like a month of standard programmer output. Especially standard programmer output after Twitter was invented and Facebook, because that's all programmers do now is read the internet all day when they're supposed to be programming. Okay. Do I want to bother with Prefetch? What time do I normally end these streams? There's no schedule. I just stream when I want to. Political discourse has gotten so much better, it was worth the productivity hit. Totally. Okay. Hey, Casey. I never do lock-free stuff. When do I use mfence? Like, what is that actually for? I know that there's like sfence and lfence that you don't really need to use on x64, but like, I mean, mfence, okay, it helps you establish sequential ordering between writes. Like, I guess you're making sure your writes are flushed or something, or your loads are flushed. I don't know. I don't know what you're making sure, but I guess if you had to make sure one thing was written before the next was written, that's fine. But I don't have a concrete picture in my head of what is an algorithm that needs that to be correct. It's for special hardware mapped ranges. So you update some data structure and then mfence before atomically swapping a pointer to that data. Data structure needs to be flushed to memory before the atomic operation happens. Right, so that's a little bit different though. I mean, so here's the thing is there's mfence for the hardware. I guess that matters for the hardware, but in some sense the compiler is also using it as a hint that you can't order things, right? Like both of those are happening. All right. Anyway, we're just going to implement mfence and not really have a test case for it because why not? Why not? Mfence. Na mfence. What? OFAEF0. Okay. This formatting leaves something to be desired, but this is like auto-generated from the manual, I guess, and maybe the generator got confused. All right. So we're just going to make sure that that disassembles to the right thing. Very easy when there's no arguments and no return values. And in the, is it double underscore mfence? Let's guess. Let's just see. No, is it single underscore mfence? No. Come on, bruh. Mfence. mfence. All right. I think that's it. I think we're done. Let's put an mfence in our test program. Whoops. We didn't put it here. All right, we mfenced. That's really great. Do we crash? We don't crash. Let's check the deck. Pause. Mfence. Hey. Okay, great. I'm going to commit that. mfence intrinsic. Great. A good example is writing surfaces into a GPU. Okay, I dig it. I dig it. Yeah, there's definitely a question of what's the memory model on the CPU. And there definitely have been CPUs that didn't enforce ordering, but I think Intel rapidly came to the conclusion that if you don't enforce ordering by default, all sorts of programs are wrong that you don't intend to be wrong. That is my folk understanding of what happened historically, and so they just say, look, strongly ordered memory is what it is. And yes, in theory, you could get more performance out of a weaker memory model, but like, good luck writing software for that, I think is what the conclusion was. Let me know if that's not right, but that's my belief. Okay. Well, we go back to the list. Prefetch, that should also be easy because, oh, well, it does take an argument. Why am I moving that? All right. So let's see what this is for prefetch. So is this a number of bytes starting at an offset? Prefetch NTA T0, T1, T2. Specified by the locality hint I. Locality hint. Does anyone use this stuff? So we're just, yeah. NTA is 0, 0 is 1, 1 is 2, and 2 is 3. Casey says yes. All right. We'll put it in. We're not going to make enums for these. We're just going to put it in with an integer. Okay. So one argument, it's you're going to make it 1 byte, or 2 arguments, because there's a location and the hint is a U8. Great. Okay, so 2 arguments. Prefetch. Does the intrinsic return anything? I don't. Nope, it's void. I like void because it's never going to fail, hopefully. Okay. Whoops. Right, why am I there? I wanted to be here. I wanted to be in runner. Oh god, it's this bullshit. Okay, we're not going to copy from that. Yeah, this is more like it. Prefetch. This is in the result. Hint. Did I put that in index A? Yeah. All right. I don't know why I used index result. Whatever. Nobody cares. Prefetch. Okay, in the x64. Prefetch. We need a and then we need a move extend. Whoops, why am I editing mfence? That's not right. Okay, prefetch. OF18 and then the hint. I guess I just put it there and it doesn't matter. Hint. Oh, the hint, right. So we have a bit of a thing. The hint has to be known at compile time. which is fine. We just got to do it a little differently. Got to do a little extra to make sure we know it at compile time. And we can range check it as well. Okay. Wait. So the intrinsic... Okay, here's a weird thing. The intrinsic on Intel is just a function where you give it the hint and it does a dispatch. That's slower than you would like. So why did they do it that way? Why didn't they just make it different intrinsics? Oh, because it's not an actual function. Never mind. They don't like run code that switches and does one of these. They just look at it and pick one. All right, that's fine. That's fine. Okay, back up the bus. Okay. Hint expr is a val expression to literal or constant argument list 1. If we didn't get one, report error, site, do we have a site? Yeah. Site prefetch intrinsic requires a constant value for hint. It's a little bit of a weird hack, but it's an intrinsic, man. What do you want? What do you want? Okay, so assert hint expr type is asked literal. Literal is static cast. Hint expr and expr integer value, no, literal integer value. If hint is less than 0 or hint is greater than 3, we report error. Prefetch requires a hint in the range 0, 3 inclusive. Value passed was, comma, hint, return -1. Okay, so hint register, no, -1, and BC options is hint in the runner. BC options, and then in x64, we use RDI for this, and then okay. So okay, 3 hint RDI. Maybe that's a thing. I'm sure we made lots of mistakes. Case value 75, already used. Uh, 75 already used. $18.21. Oh my God, right. Okay. Okay, here we actually do have to switch. It's all good. It's all good. Did we put one in our test program? Prefetch, I don't know, with 1. Let's try -1. Hey! Oh, number signedness. Okay. Well, that's fine. 9. There we go. Let's change our punctuation. How's chat going? Talking about indie versus AAA. Okay. So that's fine. Let's go back to a valid hint. Prefetch. Okay, we didn't crash. Let's look at the thing. No, we do have an invalid instruction. It's weird that we didn't crash. I wish it would just show the bytes. Like, if it's an invalid instruction, just show me the bytes. Like, what would be wrong with that? Okay, prefetch. Okay, this is weird. Okay, so first of all, like what? Okay. This into memory was not right. I pasted that. That's the wrong direction. Oops. Dude, what is going on? Okay. Okay. So dest register is there. In the results slot. That's fine. So we put that into RDI. We get the hint. It's in options. I must have got the opcode extension wrong from reading the mystery alien moon language. 0123. It usually goes there. I mean, okay, wait, is opcode extension, that's the same as like, yeah, it's just mod RM. It's just an alias for mod RM. I mean, so I fixed the move. It's not going to do anything. OF18. That's like literally what it says. Okay, I'm confused. M8. What does that mean? Oh, I'm using the wrong addressing mode here, by the way. It should be like 0. I don't know if that is enough to unconfuse it. It doesn't really make sense to prefetch a register now, does it? I didn't think so. Prefetch 0, T0, right, which is 1. Okay, so we could just, so if we pass 0, we should get prefetch NTA. Prefetch NTA. Yep, great. Ship it. Any questions about what the hell is going on? All the values in the switch passing in the correct hints. Probably not. If you ask that, usually when people ask that, it's because they spotted something wrong. No, it's fine. It's fine. It's just the same number. Jacob Lee caught my 3 versus 0 before I did in chat, probably. Will prefetch always be explicit, or will the compiler insert it for you in some cases? No, it will always be explicit in this language. Where do you expect the compiler to be able to put in a prefetch that is going to be correct and helpful? Where would that even go? Can you give me an example of where it would go? Yeah, as Casey points out, the CPU does have prefetches itself because it's doing speculative execution, and that'll logjam if it doesn't, you know, do speculative memory addressing. So like, if you're going to do a prefetch, you have to really know something that the CPU can't figure out. Loops on constant size array. No, your CPU is going to prefetch that. Like if you're sequentially accessing memory, that's going to get prefetched for you, either forward or backward on a modern CPU. That just, it detects that shit. Prefetch uses different hint values. I am being told how do I know what they are? It's very helpful documentation that's not... I could look in xmm intrin.h, I guess. Wait, this is... That's a totally different file. Well, it's not here. Yes, it is the same. It's exactly the same. And there's this ENTA, which I don't even know what that is, but these are the same, these ones that we did are the same ones. Oh, 1 is T2, 2 is T1, and 3 is T0? No, it's not. Look, T0 is 1, T1 is 2, T2 is 3. Who's telling you that it's reversed? Or do you mean that I have the instructions backwards? Just a quick caveat, the CPU doesn't actually auto-prefetch linear access patterns at full speed, so even sometimes simple things need a prefetch. If you're Mr. Fastest Code Pants about it. Yeah, I haven't done benchmarking that seriously. To be fair, very few programmers in the world anymore actually benchmark their code in a meaningful, correct way for high efficiency levels. So, but I am not one of those people right now, in fact, as it turns out. So I do not have that lived experience. Casey, are you denying me my lack of lived experience? So are you telling me the documentation is wrong? Where are you getting these other T0 equals 3? Where is that? Does someone want to pop open Godbolt and see what happens if you do? Although that's running on Linux, so it might be using a totally different header file and blah. Does Godbolt have an MSVC version and not a Clang version? Does someone want to pop that open and do an MM prefetch with 3 as the argument and see what the assembly instruction is? Occasionally meow hash work has benchmarked at that level, and you've been surprised how many weird things came up. Yeah, computers are nutty these days. I definitely care more about writing fast code than probably 99.9% of programmers, but I do not optimize at the level of, like, you know, the OODL programmers or whatever, right? That's just not, they're way more serious about optimization than I am. And you have to recognize that. And yeah. Well, we don't know. So thing number one is we don't know if these defines are right because we have reports of conflicting defines. And then I guess we don't know for sure. I mean, I assume that this documentation is probably correct. I'm not gonna think that this is wrong. So the question is just, is this wrong? I mean, this is the same as this. So really, the only reason I have to believe it's reversed is someone on chat is telling me it's reversed. Just tried Godbolt. 0 is NTA, 1 is T2, 2 is T1, 3 is T0. Really? What? Yeah, someone just said from the Intel manual, and it's the same. Thanks for the privacy policy, Godbolt. Prefetch NTA 0. Wait, what are you guys talking about? It's right. Why are you telling me it's backwards? No, it's right. I just did the link that Jacob Lee 0 said, and they're in the correct order. But somebody else said they just tried Godbolt and they're reverse. What? MSVC is right, GCC is reversed. Clang is reversed. Great. I'm going to have to put a warning in the source code then. Warning! Clang and maybe GCC use the wrong constants for these things. So we should have an if-def testing this. They have the values from 1 to 3 reversed. Okay. Why not just use the predefined hints? I guess we could do that. That is a good point. Except that those are wrong. We can't use them because they're wrong, right? Or are they? Are they right? Dude, I don't know. Okay, so here's the thing. The question that is not resolved is the header file wrong or is the header file right and it's just reversed, right? Those are two different cases. So if I go to XMM intrin, this is called hint T012, right? So there, whoops, T0, 1, 2. Okay, so this is correct on this compiler. Oh yeah, we have MSVC and GCC down here, right? Okay. Whereas if I make this 3, this is T2 and T, okay. So the constants are right for the operating system. That's fine. Okay. So this will work. Computers. Computers. At least the header file wasn't wrong. That would have been real annoying. Okay. Fix for weird reversal of prefetch hints that happens on some compile. Thanks for spotting that, because I don't, like, we probably wouldn't have noticed for a long time. Use the constant for NTA as well. That's a good point. This is what happens when I am jet lagged. Also happens when I'm not jet lagged, but okay. Okay. Use the constant for NTA as well. Boom. Great. We have things. Okay, are there any questions about all that before we move on and do even more intrinsics? Questions? Comments? Whatevers? Readgsqword. Do we really want to do Readgsqword? I guess we could. What is the motivation for tackling intrinsics now? Well, it started by we really needed them now for the game for like memcopy, memset kind of stuff. And then while we're doing that, we might as well put in some other ones. So we're not going to do like AVX 512 yet, probably, although who knows, I might get a wild hair and do it. I just wanted to do the basic, most minimum things that we needed, and then while I was motivated, I'll just keep going in that direction. So we started by doing these, and then we did compare and swap so that you could do stuff. And then at the beginning of this stream, 5 hours ago, we made this polymorphic, and we made that work, and that was surprisingly easy. So now we get type checking on polymorphic intrinsics. And then most of the ones we've done here, well, these ones aren't polymorphic because they don't need to be, but like math ones are, so that you get, they adjust to the size and you get type checking and stuff. In theory, you could pass a floating point number to atomic and. Let's just, do we want to, maybe I should call also with add and increment. We don't, it'll accept a float right now, but it won't do the right thing. And I mean, there's no, yeah. As far as I know, there's no atomic add for floats, and it wouldn't make that much sense. If you want to do atomic math on a float, use compare and swap. What came up that was blocked on memcopy and memset? Nothing was blocked on it. It was just, we were calling regular old procedures for those, and they were just slower than you want them to be, you know? Please document the actual values. I do. I typed it way back right here. Boom. We didn't make enums for it, but it's right there. It will give the next representable float. Do I have any thoughts on Dota 2 auto chess? No, I tried looking at it a couple weeks ago. And it's just too, anything, see, Dota is so complicated to begin with. that anything based on Dota is just smothered in too much nerd sauce that I would have to learn to understand the game. Like, you know, I saw some guys moving on some squares in kind of a chess-like way, but like Tusk was doing walrus punch and whatever, and I'm like, I don't want to figure out what this is. So I imagine it's only really going to appeal to Dota players. Like, on the one hand, you have the benefit of having something that is going to interest all the Dota players, right? On the other hand, it's going to turn away almost everyone who is not a Dota player. And there's way more people who do not play Dota than people who do play Dota. So it is what it is. And is it really incredibly deep, or is it just complicated, right? Because Dota, I guess, is deep, but it's deep through being complicated, which is not a kind of deep that game designers tend to find very elegant or beautiful, right? Like, anyone can make a game really complicated. And then you just make sure it's not totally broken and totally unbalanced. And then, ta-da! What's my opinion of Google Stadiums? My opinion is, how are they going to fit the whole stadium through the wire? I don't get it. How are they going to sell hot dogs? By the time you squeeze the hot dog through the wire, it's going to be like a really thin hot dog that nobody's going to want to buy. It's both deep and complicated, has a lot of RNG, but is very manageable, which makes it quite unique. How is it chess with RNG? Like, somebody square that for me. Donald Trump's six-dimensional chess. Is that a thing? Oh, you mean like, yeah, okay. Now I am getting a sugary beverage. It's strategy with a lot of different possibility trees to go down. You buy your chess pieces from a randomly generated set, so you need to keep looking for those you want. I don't like deck building games, so yeah. That's the two worst things. So being based on Dota is smothered in nerd sauce. And then being a deck building game is also smothered in a different flavor of nerd sauce. So it's like double nerd sauce. If you get good enough at trading card games, you could lose $100 million in Bitcoin. I thought they were starting to get that back now. Didn't some of that, I don't know. I thought I heard that. Is there not something interesting in Dota being seen as inelegant but so wildly successful? Not really. So people at Valve said that to me. I'm not going to name names. And I didn't say this back to them, but like, okay, Dota 2 has a lot of players, but it's a tiny game compared to League. And League copied Dota 1 but made it simpler. So if you're going to argue that that complication makes the game better, then why is League kicking your ass? Why do you wish you were League? You know what I'm saying? Did I find that contact from Ready at Dawn? I haven't checked in a while. League came first? No, I think Dota 1 came first, didn't it? Like, Dota 1 was a Warcraft mod a really long time ago. Dota 2 came after League. Yeah, but Dota 2 is like the same game as Dota 1. Dota 2 is a Dota 1 mod, basically, in terms of game design. All right, later, Casey. Okay. If network effects matter that much, then why is Call of Duty Blackout dead and everybody's playing Apex Legends? Blackout came out before Apex Legends. The network effects matter a lot. Everybody should be playing Blackout. All right. Let's do some more intrinsics. We did prefetch. I guess we're doing Readgsqword. So we pass an offset. That's a 32-bit. I'm starting to get tired. So we're going to have an offset register and a result register. Black Ops is designed to last for a short while. No, it's not. They wanted people to still be playing that. Just like Apex wants people to still be playing it. Okay, Readgsqword. have a result. And Readgsqword in Windows is this double underscore, real low level stuff. Readgsqword offset. Offset is BC index A.U32 Readgsqword. Let's just go ahead and do the x64. Okay. Put that in RAX. Four. Readgsqword. RDGS. F3. RexW OFAE. That's weird. Okay, that's the base. Wait, am I supposed to implement? So I'm supposed to load the base and then add an offset. Okay, why doesn't the intrinsics just give me the base if that's what the chip does? The opcode bytes are 65488B00. What? That doesn't look anything like what's here. Okay, so you're saying don't use this, although it seems like you could use this and then do the add thing. Okay, so you're saying it's just a different thing. Okay. So move RAX GS RAX, right? All right. So output dot bytes 65488B00. Okay, and then we got to return RAX. Bam. Sham bam bamina. Okay, so somebody said then a long time ago, if we read with OX48, that'll give you the current thread ID. I guess I could do a print. Well, let's do one at the top and verify the assembly. Thread IDs, Readgsqword, GSRAX. Okay. Well, that's great. I mean, it could have been EAX in the brackets and not RAX, but whatever. I guess because we're assigning it to RAX. Yeah, it probably is for both. Yeah, you're right. Okay. Okay. Read.js base is a kernel-only instruction. Okay. Readgsqword. Thread ID is 15948. I mean, it's a quasi-random 32-bit number. Thread proc. I mean, that's going to be a we could put a mutex around that. Huh? I mean, are those what the thread IDs are supposed to look like? They are different for each one. Oh, mask off the top 32 bits. I mean, they were 0 anyway, but... I mean, I can't tell if I'm accidentally reading the, the random number generator. No, those don't look random. They're within the same relatively low range. Check out with get thread ID. We haven't done get thread ID. Windows get thread ID. Can I make, do I need get current thread for this? Get current thread ID. Okay. dword. Okay. Wait, what did we just do? Why, if I get current thread ID? Oh, this is for thread. Okay, I just call get current thread ID. We didn't actually need get thread ID. Because we have get current thread ID. Yeah. Undeclared. We're not like... Hey, check it out. That's great. You've seen my context structure in a U32 thread ID. Yeah, but that's our own thread ID because we wanted integers that start at 0, I think. That's separate from the Windows thread ID or any operating system specific thread ID. Okay. Does it work here? Yeah, so it's there and there. Okay. So we have successfully done Readgsqword. Wow, we might get through all these tonight. And if we do, I'm going to be happy for one night. And then it'll be Miller time. All right. Comp exchange 16B. So I guess this returns a bool as well. And let's say dest is a pointer to void. Value is also a pointer to void, right? Let's look up. Comp exchange 16B. Compare EDX EAX or RDX RX with M128. If equal, set the 0 flag. Oh my God, what? All right. So 0 flag contains our thing. And load RCX RBX into M128. Okay. So should I pass these as numbers into the API? Like, should I do this or should I just have them be old value high? Like that? So that you don't actually have to have them in memory in theory. If you want to be cheeky, you can also use it to read the number of processors in the system. You take the keyword, you add OXB8. You cast it to U32 pointer. What? Take the return value of OX60. Yeah. Let's see. Print number of processors. Readgsqword OX60. We're going to hope nobody has more than that many processors. Oh, we might as well do that. All right. That's a lot of processors. So we got even more processors at runtime. I don't think that's... The normal use case is comp exchanging two 64-bit values at once. Oh, right. Old value 1, old value 2, new value 1, new value 2. But they have to be consecutive in memory, I guess, right? Can you do inline assembly? You cannot yet, but someday you will be able to. M128 points to two values next to each other in memory. Yeah. And they have to be aligned, right? And all that good stuff. You meant cast U32, Readgsqword. Why do you have to dereference the pointer to... Oh, it's a pointer in the value itself. Really? Okay. Number of processors, 24. That's got to include hyperthreads. That's not right. I have 6 physical processors, or something like that. It includes hyperthreads. Okay. Number of processors, including hyperthreads. Okay. Well, that's a thing. Thanks for that. Now we know how to do a thing. All right. So, what was I even doing? We were doing comp exchange 16B. starting to get tired. Okay. All right, so I have a problem. My problem is I do not have enough registers for here to fit this into a bytecode instruction naively, because there's just too many values to fit in the bytecode instruction. So you know what, I might, just because I'm getting tired, I might delay this till the next stream, because we're going to have to do something creative, like have these be in 4 consecutive registers. That's not really good, because then that means you can't really optimize them and delete registers or whatever. Dude, no asking to hack people in this channel, please, regardless of who they are. It's not what kind of channel we run here. So sometimes when this is very rarely an issue. Sometimes when it's an issue, I break it into like 2 bytecode instructions, one that does a prep. You know what, let's just do that. The bytecode format doesn't have enough slots for us to put all the values in one routine, so we do a prep instruction that sets up the old and new values. Then the next instruction that actually does the exchange, these should always remain sequential when fed to the back end. So the prep instruction just sets a destination pointer, which only needs us to save one thing. Okay. So we're going to need a prep instruction. so we're going to have a old value 1, old value 2, new value 1, options is new value 2. All right. Okay. So we need to get these. Dest register, old value 1, old value 2, 0, 1, 2, 3. Okay. All right, so we need a return value. We're going to need to save two things in the prep. Okay? So in bytecode.h, so we need to save these. Where did I define this? It's in bytecode runner, the one place I didn't look. Okay. So we need some state here. So stupid, but this is what we're doing. Int prep dest register okay. I could also just put, no, it has to be there. All right. Great. For the prep, okay. Let's just make sure we compile, which we probably don't. No. Hey, we compiled. All right. So we've got a dest register. We've got a return register. Well, okay. What is our intrinsic? Intel Intrinsics guide. Oh, it's interlocked. Interlocked compare exchange 128. Okay. Compare exchange, not exchange compare. 128. Dest. Oh, God. The Windows API wants it in memory. So new value 1. And the even worse, wait, this is a little endian machine. So low goes first. High goes first here, but low goes first there. Oh my God, dude. Oh, this is a long 64. Old value 2, and then old value 1. We're definitely going to make sure this works in bytecode before we do it in native. All right. Auto dest is record registers dest register dot pointer. Auto. So the old values and new values are here. Old value 1 is record registers BC index A dot U64 to new BC index A index B index result options new value 2. Shouldn't whatever value 1 come first in memory? You mean here? I don't think so, because it says low and high, right? But if this is a long 64, because we're on a little endian machine, low comes first in memory. Oh, wait. No, you're right. Okay, wait. This is correct. It's these that have to be... I mean, it doesn't matter. They just have to be reversed from each other, which is annoying and stupid. That's my theory. We're about to test this. Oh, we got to return a value. No, return register, not index result. Almost screwed that up. That's a little bit scary. It's probably less error prone to do it the other way. Whatever. Whatever, man. Okay. So slot A Okay. Slot B. I don't know. Bad food. Okay. So, data is 2 U64, data 0 is slot A. U62 all right, so 3, 4, 5, 6, 7, 8. Actually, wait, what? What am I looking at? This like totally didn't work. Oh wait, what? We're like 1 digit off or something? Okay, it's little endian. Oh right, it's little endian, so we should see it backwards. FODEBC9A, FODEBC9A, yeah, okay, no, it's fine. It's fine. Let's just do it differently. So it's more readable. I was real confused for a second. Okay, great. So, actually, we don't want that because we want it to be in modifiable memory. So before exchange, after exchange, okay. So we modified it. That was fine, but we don't want to modify it this way. We want to go comp exchange 16b data.data old value 1. So it's going to be I guess like that. New value 1, new value 2. All right, so slot C. Okay. Right? Okay, we got unknown instruction way down there, but that's fine. Okay, our exchange failed, so we messed up the arguments in some way. And the only way we could have messed them up is the matching is wrong. Well, the most likely way that we messed them up is the matching is wrong. Actually, there's plenty of other frickin' ways. Like all this cross-referencing can be wrong, but whatever. New value 1. Oh, wait, the comparand. All right. Old value 2, old value 1. Comparand. My name is Professor Comp. Why can I not compile? All right. Okay. We're just going to break in there. It's going to break in there. See, we've got enough going on. Oh, it's in runner. Okay. Let's see what we get. Old value 1. Old value 2. That doesn't look right at all. Old value 1 is garbage. Okay, these are like totally, like new value is crossed with old value. What is going on? Okay. New value 1, new value 2. New value 1 is incorrect. Oh, because we're off by 1 here. That is certainly not a recipe for anything being correct. Now, when I reverse the, let's re-reverse these for a second. Because, like, there's no reason to believe that that was the right thing to do. Okay. Hey, look, it worked. Recomp exchange 16 bead in the interpreter. Now let's do it in the not interpreter. Comp exchange 16b prep. So we've got to do this. Garbage. It's not really garbage, but you know. Thanks, Emacs, for deleting my file. Okay. So we need an old value and a new value. Okay, dest register is this. Return register is this. Okay. So our dest register is going to be dest register. And when we return, we're going to do this. So that takes care of those. And then old and new values is like this. So what does the instruction want? RDX, RAX, our old value 1 and old value 2. Old value 1, old value 2, RDX, RAX, and then our CX, our BX. Okay, and then we got to do the actual opcode. Readgsqword, OF, C7, opcode extension 3, no, 0. I don't actually know. I'm going to put 0, 1, RDI. And I guess we'll see what happens. Step in. Oh wait, did we recompile the program? We rebuilt the compiler. Okay, we didn't because I saw the error up there. Good, that would have been confusing this late at night. Can't even get to the right window. Okay, disassembly. Comp exchange 16B. Woohoo! Wait, what is O word? Oh, octaword, dude. Octaword, DX, AX, CX, BX. Octaword. Maybe it works. Did you ever consider that it might actually work? It does. Wait. Haha, okay, here's the problem. We're running this at compile time, and we're modifying this array, and then we're saving that modified array into the executable, so it's already changed. So we're going to do this. We're going to go data is a 2 U64 slot A, data 1 is slot B. That's fine. Okay, so here it worked. Here it didn't work. Okay. Oh, don't forget the lock. Thank you. It still didn't work even without the lock, but OXF0. All right. Like, why does it even let you do those without a lock prefix? I don't claim to know, but maybe there's a reason. Look at all those instructions. All right. This is way more instructions than it should be, but dude, we don't even do register allocation. So like, our x64 backend is dumb as a post when it comes to generating instructions. You almost couldn't get more dumber. Boom. 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 So we're just loading up our constants into memory. See, we're loading these 4 constants into memory, and then we're loading those 4 memories into these registers. Could have just loaded the constants straight into the registers. Would have had 1/3 as many instructions right here. Anyway, yeah. Okay, wait, is the result in RAX, first of all? No, it goes into the 0. So that's one thing we did wrong. We've got to, or I did wrong. I'm not going to blame anyone there. That's not the problem because it still didn't like work. So we're passing the arguments in the wrong order, but so is set A the right thing? So we want to know if the 0 flag is set. Right, so set CC, set A, no, set E, really? Why is this different from the other frickin' one? Like what? Comp exchange normal. We did set Z. Okay, same thing. This is fine. We have this problem again where we want the rest of it to be 0. But we don't have a choice about what registers we use. Okay, if I 0 RSI, a move from RSI into RAX ESI into EAX, so we don't have to do a RexW. Total hack. Can anyone think of a better way to do this? You've recently finished Braid after several painstaking hours of trying to solve elevator action. Elevator action. I'm glad you enjoyed the game. Right on. Could use RSI or move ZX. You can choose the register because you're just putting it into memory. Yes, I know, but the thing is, like set Z only takes a register that has a low byte, right? Which I think is A, B, C, or D. I don't think I could do a different register for set Z. Move ZX. Set Z SIL. What is SIL? Oh, you can do that? There's an SIL? I didn't even know that. So I could just do this. Let's see what the assembly looks like for that. Thanks for the help. Okay. Well, I should just make that variable global because I think I prefer that to that anyway. Makes more fit on the screen, buddy. Step in. Okay, what are we even looking for? Comp exchange 16B. Lock comp exchange RDI. SETI DH. That is not right. Only if you use Rex W. Okay, good point. It's not Rex W though, right? It's going to be Rex R or something. Thought it was Rex R. Plain Rex. What is plain Rex, by the way? I don't even know. I just use Rex W. Is it... What is the value of... Okay. The layout for the Rex prefix is as follows. W RXB. I guess it's Rex R, right? Oh, I already defined it. Rex R. It is Rex W because that disallows high register access and makes it SIL DIL. Okay. Thanks, people who actually program in x64, which I don't really. Probably would have taken me 2 hours to figure that out of tiredly reading web pages. Okay. Well, I didn't expect the Spanish Inquisition. Wait, what? Okay, wait. What the hell was this? This is something that I pasted from somewhere else. Okay, hold on. Oh, okay. This is the actual, right. This is the actual comp exchange 16B. Okay, here's what's going on. These are all unchecked adds to this concatenator thing. And what unchecked we got kind of lucky to get the crash, I think. What happens is at the top here, I reserve some number of, 400. This can't be more than 400 bytes. All right, let's just run it. Let's just run it. See what happens. Let's not theorize too much. Did I not recompile it correctly? Okay, whatever. Recompile it correctly, please. Okay. Okay, well, it didn't work still. Let's look at the disassembly again. So many pages down. Okay, lock comp exchange 16b. Set E. I guess that's the alias for, and we Readgsqword ESI, which should clear the top bits as well. It shouldn't matter because we're not paying attention to the top bits. May not matter, but should be plain Rex. Well, let's do that. Rex is just OX40, right? Right? Disassembly. Blah, blah. Okay. Okay. Well, it is what it is. So maybe I just got the arguments incorrect with respect to the memory order. So let's try swapping that. So our AX, whoops, our DX. If that's correct, then the new values will be in the wrong order, and we will have to swap them as well. Hey! Okay, it works. Yeah, so it's the thing about being little endian means they go in the opposite order. I mean, I don't know. Do people have an opinion on, like, I guess new value 1, I feel like it should be the first thing in memory. We shouldn't be treating it as a 128-bit number. We should be treating it as two different numbers, right? So old value 1 should be slot A, old value 2 should be slot B. That's my official opinion, which is different from if you were treating them as a little endian number, kind of. You can't really, I don't know. I don't know. I'm too tired. I'm simply too tired. We've been streaming for 6.5 hours. And, okay, is that the same result as 12FE? 12FE, all right. Someone's saying I didn't use the new Rex constant. You're right. You're right. Let's do that. Let's make sure that works. We'll just double, triple check, even though it's going to work. Well, we're not actually looking at the return value. We should do that. We're just like, it's working now. It's doing the exchange, but that doesn't mean our return value is correct. Okay, so it's still the right thing there. Okay, so foo. Result success 16b is this. Dude, we did so much today. Oh my golly. Oh my golly golly. All right, success 16b is true at compile time, true at runtime. If we, let's make sure it returns false correctly. So if we go slot B +1, it should fail. There we go. It didn't exchange. False. Didn't exchange. False. Great. Great. Any rec swaps high registers for sil, dil, spilpul, spipple. Now the comment about rexw is not needed and confusing. Well, just do that. Okay. You thought it would complain about missing return where? Does the return -1 or return result register do anything? It does generally, but maybe it doesn't. Because the thing is, when we call this, we already know what the return register is going to be, so we might be actually ignoring this. What are you saying is the missing return, though? Is hack comment still relevant? Oh, no. Thank you for reading the comments. Zero this as it will hold our return value, but do it early so it doesn't mess with the zero flag. See? Commenting. Commenting. Consequences. Great. Boom. I'm getting pretty tired, but, well, do we care about these other two? We could be done. Compare and swap intrinsic from earlier stream. Oh, but we fixed that later. It did, there was a warning. There was a warning, I just wasn't paying attention to it because I get a lot of warning output, but I think I saw that and fixed it. Yeah, see, we have a return there now. We were missing one, it's true. And we were getting a warning for it, I just didn't see it for a while. Do I use many abbreves in Emacs? I don't know what an abbreve is, but I probably don't use any. You saw it working before the return, though. Yeah, I mean, it was working, which again leads me to believe that the caller doesn't actually pay attention to this return value, which is why it worked. Because it knows the return register base, which is all we'd be returning anyway. It's redundant. Probably should just get redesigned to not have a return value, but yeah. Okay. Should we do Readgsqword or Readpmk? Should we do either of these? Does anyone have an opinion? What do y'all think? I've got abbrev mode on. Yeah, I don't know what that means. I probably hit a random key. Yeah, there's no such thing as complete the entire set of intrinsics, because there's a bunch more that we could do some other time. You know, I'm feeling pretty good about this. I think I'm going to quit while I'm ahead. And everyone wants me to do more intrinsics. What's wrong with you people? RDPMC is really complicated. Exchange would be really easy. Let's do exchange. That's fine. We'll leave RDPMC as a question mark. We'll do exchange. What should we call it? Atomic exchange? Did we put it in? Yeah. Is there a better name? I don't want to call it XCHG. That's just, eh. Okay, so we don't have an old value. We just have a new value. Do we need a result? What is the Windows one? It's interlocked exchange, right? Interlocked exchange 64. It's not that easy because we have to do the branching out based on size again. Returns a prior value. Okay. So compare and swap atomic. I mean, if it's called atomics, let's call it swap. Like, yeah, okay, whatever. Dest is a pointer to $t. New value is a t. Old value t. Right? This can't ever fail. Is that the idea? Because we swap with it. Yeah, who cares? Like, yeah. All right, atomic swap. We'll harmonize all these names at some point. Like, don't forget to not use lock. What happens if you use lock? Do you just get wait, what happens if you use lock? You just waste a byte, I guess. Yeah. Don't compare and swap. That's a good idea. I mean, I should call this atomic compare and swap if we're going to have this atomic prefix. But it's just compare and swap. That's what it's called in computers. I don't know, man. I don't know. All right. All right, so atomic swap dest register, new value, result register. Don't put old value in the options. Great. Got to do all this bull, Pucky. Exchange, dest pointer. Okay, no old values. No old values. No old values. No old values. Instead of interlocked compare exchange, it is interlocked exchange. So we just get rid of the now we find out that that is oh yeah, wait. We gotta not pass that as an argument. And we're probably getting the wrong, okay. So this goes, this goes, this goes, this goes, just put a semicolon so as not to screw up people's indentations. Okay, so old value goes, and then we've got to return the results as a, depending on the size. $16, 32. Actually, let's put this outside the if-def. $64. All right. Okay. Well, let's do data sub 0. After non-compare atomic swap, let's do this. Okay. Atomic swap data.data slot C minus. Cannot negate an unsigned number. There's 2 ways to skin that cat, buddy. All right. Fee. Old value. Oh, wait. What? That's messed up. Okay, hold on. Let's pick a totally different number that is not related to any of these. Okay. Just to be not confusing. Okay. Fee. Okay, this is confusing me because we're like 1 off and we're not changing anything. I mean, that shouldn't matter, but why are we getting data sub 1? That is messed up. Let's make sure we didn't. Atomic swap, dest register. New value. Dest register, new value, result register. Desp, new value. I'm calling, oh, really? Is that all I'm doing? Thank you. That's a paste error. Thank you. That's ridiculous. Okay, not old error, old value. It was an old error too. Oh boy. So we didn't return a value correctly. This is, so Visual Studio in the debug runtime, when you have uninitialized heap memory, it clears it to CD, 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 CD. And I have a blanket assertion running that detects that. The swap also still failed, but I think I'm trying to print old value and it's got CD in it. It's a CD old value. So U8, U16, U32, U64. I don't get it. Let's just see what happens. Haha, thank you. I'm making, this is why you don't program once you get tired. I'm making so many mistakes. Thank you for spotting that. Holy cow, that would have taken a while to debug too. Probably. Oh, we got to rebuild the compiler. So the reason we were getting the CD, CD, CD is we emitted the wrong bytecode instruction and didn't, you know, we had a garbage value in the register for one of the things because that one had one more argument than this one and so on. So many mistakes. There we go. We swapped in this, and the old value returned was this. Now, all we got to do is do that same thing in the in here. Oh my God. All right. Who said this was going to be super easy? Okay, there's no old value. That was in RAX. Zero RDX. We don't bother putting the lock. I remember that. We did a ton of intrinsics today, man. Oh man, we did so many intrinsics. Okay. Well, xjig. 90. What is RW and RD? Why did this get such a short opcode? Okay, we can exchange. Okay, so if we put this in A, we can use the short opcode. Not that it matters that much. Okay. Wait, exchange register? No, we don't want to register. We want the memory ones. Hmm. 87/R and 86. Eight seven Readgsqword 87, and then so /R. I mean, I guess it's this, right? Who even knows? And then, okay, our return value is different. So our value goes back into A. Do this every time, dude. All right. Did it work? It worked the first time. I mean, for 64-bit. You don't need 0 RDX. Good point. But we don't need that anymore. Okay. This is great. And we're just going to try this at some different sizes. Although, we would have to... Okay, let's make a different test for exchange. Because this one is like coupled to it being big, because that's the whole point of this instruction. So let's... to swap is 2 of something. Oh no, to swap is just, you know, 1, 2, 3, 4. No, 9876, right? Okay. And then we'll get rid of slot E. Oh, we did. And 9876. 2, 2, 2, 2. Whatever. Small enough that it will fit. There we go. Okay. T-swap is 9876 old value. Right. There we go. T-swap 2222 old value 2694. What? $2694. We made a paste error over. U8, U16, U32, U64. What? Is it right in machine code? 2694. What? How is it? Wait, what? How is it the same? Can someone... Why am I crazy? How is 987... Oh, because it's hex, and it happened to not have hex digits. Ha ha. Okay. We're getting punchy. All right. Well, it's Miller time. Oh, we got to try it at different sizes. We're verifying that it's Miller time. That was the whole point. U32. 976, right? And when we get down to U8, we'll just change the numbers because it won't accept them. The compiler won't accept them. 2222, 9876. All right, and then like if we go U8, it's going to say what you talking about, Willis, right? So we'll just go 98 and 22. It is Miller time. The complete RDPMC, it's not a user instruction. Okay, well then we officially did every intrinsic in the known universe except for all the ones we did not do. Great. We did so much more than I plausibly thought we would do. Good action, everybody. Let's make sure, now that I've checked everything in, let's make sure we can at least compile the game. Now watch, the compiler just explodes, doesn't build the game, and then I have to stay up 8 hours debugging it. What happens is the pointer is long and the immediate is short. Well, so here's the thing, is it's a polymorphic procedure. Whoops, not jail. It's the jail programming language. So atomic swap, right? So it's polymorphic. It takes an old value, new value. They have to be the same type. So if you give a number that's small, it'll get casted up if that's valid. If you give a number that's too big, you'll get a type check error. we could have done this with you know, floats and whatever, and it would have worked. Ta-da! Okay. We built the release build. We built the video game. We run the video game. Yeah, it's actually C++ does that too with standard atomic. It's just it's really gross the way C++ does it. But it's the same thing. I mean, standard atomic is kind of object-oriented in the way it's set up, and this is not. That's the main difference. Also, our generics give you reasonable error messages and stuff. Everybody, it's Miller time. 7 hours and 10 minutes of stream. We did so many things. Let's go over the list of all the frickin' intrinsics we did. Okay, these were already there. So first we made this polymorphic. We did all these math intrinsics. We did these CPU ones, prefetch, the Readgsqword, found out how many threads we have. Compare exchange for big values. Exchange with non-compare, we did mfence. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 17 things. We'll call it polymorphism one thing. And I got dinner in the middle of the stream toward the beginning. So 17 things in 7 hours is 0.4, well, times 60 minutes. 24 minutes per thing, 25 minutes per thing. That's not bad. And, I mean, we had to implement every single one of those twice because once in the interpreter and once in the compiler. Yeah, well, I got up late today, so it's not totally 7 hours after work because I was traveling in Asia and my time zone is real off. So I got up at 6 in the morning. I was like, oh, that's not quite enough sleep. Let me go back to sleep. So I went back to sleep. I woke up at 2:30 in the afternoon. So I slept for like 14 hours last night. It was way too much, or last night and today. And so then I did a couple hours of work, but it's, you know, this is really like 7 hours of actual serious work. And then I did a little bit of prep. I did a little bit of like reading up on lock-free algorithms. If anybody still knows good references about where to read about lock-free algorithms, I could check that out. Somebody did send me this concurrency freaks situation. I thought there was another page that went with this, but maybe I didn't correctly stash it. Anyway, I'll be reading that tomorrow. Now it's time for Baba. No, it is not. I'm too tired for that. How many more intrinsics do you want to have? Well, I mean, probably the next set to do would be like AVX 512, which... I mean, there's a lot of things here, okay? This is like hire the summer intern and make him look at this. I mean, some of these are maybe like variants on the same instruction or something, but like we did 17 today, is that what we said? So we did 4, 8, 12. We did that much. out of this giant ass list. Please support SC2. Your precious little CPU can't handle AVX. Well, then that's even more. Has rotate been implemented? We actually don't have rotate. That's a good point. We could do an intrinsic for rotation. We were thinking at some point that we would. Let me put that on the to-do list. We're thinking at some point that that would just be an operator modification because it's goofy that C and C++ don't have rotation. But yeah.